Hi everyone, we're going to talk about young children as engineers today. I am Brittany Evans and I teach first grade at Northern York County School District in Dillsburg, PA.
And I'm Rachel Weidenhammer. I'm a fifth grade teacher with the Wilson School District in Sinking Spring, Pennsylvania. To begin, we would like for you to read a short article that we found on STEM education in elementary schools. It should be posted on the discussion board for our class. And after reading, we'd like you to post your thoughts or response to the article on our Padlet that we've created. It's really simple. Just click anywhere on the screen and a text box will appear and you can start typing.
We're going to be examining how to start children at an early age in engineering, and we're looking at what initiatives exist inside and outside of schools. One quote that we found that kind of led us through our whole presentation was that engineering is a powerful way of teaching, learning, and extending education methods. So we're going to examine how it's used in the classroom.
So the first thing we're going to talk about today is the Partnership for 21st Century Learning. And this is a nonprofit organization that helps students to be ready for our ever-changing society. So it is a nonprofit organization that works with businesses as well as education organizations, and they have come together to just develop a framework and some other resources to help educators prepare their students for our globalized society. So this first part here, if you see this rainbow arc, is their framework. And the framework is basically made for the teachers as well as education organizations to kind of understand what 21st century learning looks like, and it helps students to just understand what it is to live in this ever-changing society. So it's the skills and the different groups that are accountable to helping students to develop those skills. One of the things that have come out of the framework are the 4 C's, which is something that many of you might be accustomed to seeing because this is something that I think a lot of schools are trying to implement. The 4 C's is basically just a more user-friendly framework of just developing that 21st century mindset, combining reading, writing, and math, and incorporating the 4 C's into that. And these kind of skills, the communication, the collaboration, the critical thinking, and the creativity, these are easy ways that we can implement some of those mindsets of the 21st century into our everyday curriculum. This tool right here I thought was very interesting. It's actually a planning tool that school districts can use when they're trying to implement more 21st century learning and the 4 C's into their school. So it actually can take either teacher leaders or administrators through a series of kind of like questioning and things like that, thinking about the different parts of your school and how you can implement STEM or engineering into your school. So it's looking at learning, the teaching and professional development involved, your assessments and accountability, leadership and culture, and your infrastructure. So it's a really interesting tool. You should definitely check out on their website if your school is looking to incorporate any kind of STEM program at your school. All right, the next thing that I'm going to talk about is the next generation science standards. This is another really great foundational tool to use. These science standards were developed due to a few different things. Brittany and I both did the elementary STEM kind of topic for our first paper. And one of the things that was definitely a glaring thing is that there's a lack of achievement in U.S. students as compared to other global countries and things like that. And it's definitely, these next generation science standards is trying to help to bridge that gap of that lacking achievement. It's also helping to prepare students for the modern workforce, as there are many students who will probably have jobs that are not even created yet when they get out of high school. And also just to help our society to become more math and science literate. So the Next Generation Science Standards actually developed this framework for science education, and it helps to kind of develop a format and a framework for what students should be learning K to 12 in the fields of science. And I'll explain a little bit more on our next slide about the different components. But basically, it's just starting to build one on top of the other the different building blocks of science. So science used to be a lot more of memorizing and things like that, and it obviously has evolved and changed. It's kind of hard to see in this small model, so I will make sure that I make this image available to you on our discussion board as well. But it's just an interesting comparison of what science education used to look like and what it needs to involve now. So back to what I was saying about the different types of science learning, the Next Generation Standards incorporate 3 different dimensions. The first is practices. So that's actually trying to teach kids what scientists do to investigate the world and what engineers do when they're designing or building things or solving problems. The key ideas is the science aspect of it. So it's definitely breaking it down into 4 main disciplines: the physical science, life science, earth and space science, and engineering. And then cross-cutting is taking those 4 main areas and kind of seeing how they fit together. And there are quite a few really good resources on the Next Generation website for educators. There are different pathways. There's some sample tasks. They've developed them out for middle school and high school, but they did say that elementary tasks are coming soon. There's also rubrics for lessons and units, and obviously the standards to help you navigate what you should be doing in your classroom.
So thinking about those 4 C's and then those next generation standards, we found engineering is elementary. And in my paper that I had written, I actually looked really closely at engineering is elementary because many research articles looked at this curriculum and program. So it's a curriculum and professional development based on engineering. It was developed by the Museum of Science in Boston. It's created for students in grades 1 through 8, and it's also for educators. It's set up into 3 different curriculum pieces. The first one is for grades 1 through 5, and I actually wanted to pull up the site for you to see. So this is in the curriculum for those grades 1 through 5, and it has 20 different engineering tasks. And as I was looking through each of the tasks, I really saw how it did already align with the science curriculum. So just adding these engineering tasks within the curriculum elements that you're already teaching, I thought looked like a great idea. While this curriculum needs to be purchased, I do think that you can gain some ideas from just looking at the overviews and images that they have. So your district wouldn't necessarily have to purchase it for you to kind of get a starting point for using this curriculum. The next element is the engineering adventures, and that's actually an after-school program for grades 3 through 5. And this is a free curriculum. People hear me, free curriculum. When you go on to the engineering adventures, you can see the curriculum units, and you can actually click on them, and you can download the lesson plans, the student worksheets, everything. It has it all. It has it scripted for you, so you could follow it right along. And it even includes the materials list. So you would have to get the materials on your own if you were not going to purchase the materials through this site, but you can purchase the materials on the site. But as I was going through and I did download several of the lesson plans and student books, they're very thorough, free, I might add. And I definitely see them being potentially used within the classroom, even though it says it's an after school program. And all of the materials that were used, you probably already have access to through your school or in your classroom. It didn't have too many crazy things that you would need to purchase. So I thought that was definitely a useful source. Another one was Engineering is Everywhere, and again, that looks very similar to the Engineering Adventures. It's just for the upper grades 6th through 8th, and it is free curriculum as well. So you would download the lesson plans, download the student books. You would just have to get the materials. But like I said, you could also purchase the materials through the site if you didn't want to take time to find those. Each of the programs or curriculums rather, they follow the engineering design process, and they have this image. You can download it as a PDF to even print out and use in your classroom currently. It has the 5 different steps of the engineering process, which was similar to what we had outlined earlier in our class. It also, Engineering is Elementary includes professional development aspects, workshops and training for how to implement the curriculum, but they also have a webinars link, and they did have several webinars on there that you could explore, but I just went back on and they took them down because they're going to put more up soon. And I did fill out a form to see if I would apply for free webinars to give them response, and then I could get a grant money to check out the curriculums. So I'll let you know if that happens because I'm doing that in April. Some additional resources that we found were the Royal Academy of Engineering, LEGO Education, Connects Education, and even code.org. All of these resources provide more ideas for engineering topics, or just how you could incorporate it in the science content that you already currently have. And we're going to make this list of resources available to you. We also found some camps for students. So these would be outside of school elements that your students could work or could go to, you could promote through your classroom. One source I found was Engineering Education Service Center, and you could click whatever state you live in and it would find all the different engineering camps available in that state. I also found a franchise that I thought was quite intriguing. It's called Engineering for Kids, and it's for children 4 through 14 to do STEM activities. They're after school programs, camps, classes, workshops, birthday parties. They just had many great opportunities. It was similar to the Engineering is Elementary in the fact that it had 3 different levels. And within those 3 different levels, they had many different engineering programs and topics that children could be doing.
I also found this really nice infographic of ways that you can bring STEM education into the elementary school. So this is another image that we'll make available on the discussion board so you can see it a little bit bigger. And Brittany, if you want to go to the next slide. The last thing that we wanted to talk about was that there are obviously some setbacks with trying to bring engineering and STEM education into the elementary school setting. Many elementary school teachers feel that they have a lack of professional development and they feel unprepared to teach engineering skills or principles to their students, and I think that's why many of us are probably taking this class. But it's definitely something that I think that makes a lot of teachers feel uncomfortable, and that's awesome that Elementary is Engineering has some webinars and some other things to help to give that professional development. Another setback is district buy-in. Some districts don't really see the benefit or the need to incorporate STEM or engineering at the educational level, although I think that that's changing a little bit as these 21st century skills are becoming something that we need, and then finding the time for sure.
If you have any questions, you can put it in the Padlet or let us know on the discussion board.
Thank you.
Thank you.